Okay, so now we're doing exam 1, part 3. Number 10, softball is being thrown upwards from a height of 4 feet, initial velocity, blah, blah, blah. Okay, so this is the equation that models the height of this softball. Find the velocity 1 second after the softball is being thrown. So, oh, come on. Okay, so velocity 1 second after means that we're actually asked to calculate y prime of 1. So first of all, what is y prime? Well, y prime, we take the derivative, we'll get negative 30. I should actually not put those parentheses there. Well, let's say y prime of t, okay. That is equal to negative 30 to t plus 25. And now we just plug in the number 1. So negative 32 plus 25, and, well, okay, I should be able to calculate that. 7, negative 7. And the units for this, well, it's measured in feet per second. So, yeah, we should be doing this in terms of feet per second. Just want to double check my arithmetic. Yeah, that's right. Okay. Part B is the softball going up or down 1 second after being thrown. So we just need to interpret what A is doing, because this velocity, we calculated the velocity just now at time t equals 1 second. The fact that it's negative is telling us that the height, the change in height is decreasing. So the ball is going down. And I guess I can put in parentheses because y prime is less than 0. That's the reason that we know that the height is decreasing. Okay, 11. Just take a bunch of derivatives. Yeah, okay. So for this one, well, looks like it's just a bunch of power rule. So this one, the first term is going to be 9x squared. The second term is going to be 7 over 3x to the negative 2/3. And the third term is just 0, so we don't need to write anything for that. For this, we can, well, if we know the shortcut for the square root function, derivative of the square root function, we would just write it like this, 11 over 2 square root of x. For this one, I actually need to rewrite this, x to the negative 1/2 power. So then, when we take the derivative using power rule, we're going to get, the sign is going to flip, then we're going to multiply that, so we get a 2 in front, and then it'll be x to the negative 3/2, if I'm not mistaken. Yeah, no, that should be right. Okay. For this one, it's product rule. So first is the derivative of e to the theta. That's just e to the theta. Okay. So that's the first half of product rule. The second half, we take the derivative of the tangent function there. So that's going to be a secant squared of theta cubed minus 7, followed by the chain rule, which is going to be the derivative of the inner function. That's going to be a 3 theta squared. So this whole thing is the answer for part C. And then part D, okay, that's kind of complicated. Notice that we have ln inside a square root inside a cosine. So this is a chain rule with nesting level 3. Okay, take the derivative of cosine first. That's going to be negative sine ln of x, like so. Multiply by the derivative of the inner function. That's the square root is now what we are taking the derivative of, which will give us that. And then followed by derivative of its inner function, which is the ln function, which is going to give me the 1 over x. And I would just leave it like that. Okay, oh, there's a part E. Alright, so this is quotient rule, so we just go ahead and do quotient rule. Sine times derivative of the upper function, which is going to be ln of 2 multiplied by 2 to the x, plus, and then invert, derivative of arctan is 1 over 1 plus x squared. That's the first half of quotient rule. Second half is we take numerator times derivative of denominator. So I can just reread this as arctangent, and then multiply by the derivative of sine, which is cosine of x, and then all over sine squared. Okay, and so that is part E. I kind of want to just make that look a little bit nicer there. Okay. And then number 12. So logarithmic differentiation. Right, so we want to apply the log we want to take the log of both sides of this equation. So the left-hand side gives me this, the right-hand side gives me ln is going to pop that out, so we will have cosine x ln of x minus 9 ln of x squared plus 1, I think. Yes. And then we take the derivative. So this is going to give me 1 over k of x times k prime of x for the left-hand side. The right-hand side, we've got a product rule here, so that's going to be negative sine x ln x plus cosine of x divided by x. That's the derivative of the first term. The second term is going to be a 9 over x squared plus 1 multiplied by a 2x. And then to wrap things up, we solve for the k prime of x, which is what we were looking for. So k of x is given to us x squared plus 1 raised to the 9th, and then we just wrap this in parentheses, and then we can, well, since I'm on a computer, I may as well just copy this whole thing and paste it. Oh, no, that's not good. Copy, I think it's pasting it the wrong way, so let me image. No, not image. Keep source formatting. There we go. Yeah. Alrighty. Okay, so that looks right. And we put a parenthesis at the end, and then we'll be done. There's no simplifications that we can really do to that, and we shouldn't really bother in the first place. I'm just double checking, and I'm pretty sure I'm right. Yeah. Okay, and okay, that's it.